Hi, good morning everyone. Let's get started with this particular training session which is on CBO analysis, that is the cache analysis for Oracle. Okay, so the focus is on Oracle database right now. Okay, this is basically the architecture where we are seeing the different components starting from the profile file, getting into the control file, the data files, the online redo log files and the offline redo log files. Okay, the different processes which is associated at each level. So you have a checkpoint process, you have LBD, that is the read write process, database read write, you have the log read write process, the archive process. So basically these are the different architectural components of a Oracle database. Okay, here it's the shared SQL area. You can see that this is the shared global memory, that is HGA. And within this particular HGA, that is the global memory, you have the shared SQL area, you have the data buffer area, you have the log buffer area. SQL statements are shared across all Oracle processes, and cost statistics are collected for each statement. Cost statistics, here we are referring to if we follow a particular route, how much time it will take to process that particular statement. That is the cost. So cost, it's pretty important in this case because that will define the performance, that will govern the performance of a particular process, a particular statement, a particular program. Okay, now how Oracle processes an SQL statement. So here you can see that the Oracle processes SQL statement in two phases. In the first statement phase, the parsing is done. Basically the statement is parsed, the statement is validated whether that statement is correct or not. Is there any syntax error? Is there anything which the database compilers cannot understand? Then in the next step, after the parsing is complete, the data is retrieved. Okay, so next slide, basically these are the few key terms for performance. First thing is the quality, the hit ratio for the data buffer, that is how much percent is coming from the data buffer and how much percent is coming from the database. So if more percentage is coming from the database, then that means that the buffer size need to be increased or tweaked or modified, or more number of tables need to be identified which need to be put in buffer. Then reads, total number of Oracle blocks associated in the data buffer. Physical reads, that is the total number of Oracle blocks read from disk. And user call, that is the total number of calls made to the Oracle kernel since instance startup. So let's go through them in detail. So just take note of these definitions. Most important is the quality, basically that is the hit ratio for the data buffer. Okay, then we have the user context, we have the physical reads and the reads. Okay, so here we are trying to identify the expensive select statement. Expensive select statement means what it makes it expensive is basically the component, the part, the location which makes this particular statement very resource oriented. Basically it consumes a lot of resources and they are called as expensive statement because they consume more memory. The memory consumption is very high, the CPU consumption is high, the physical IO is high. So that makes the program expensive and the statement expensive because it uses the memory extensively. Okay, the important resources on the database server that are limited are the CPU capacity, the memory, the number of physical IO definitions that can be performed. Okay, improper or unnecessary use of the database buffers results in displacements of other data blocks and affects the overall system performance. Displacements of data blocks that are needed to frequently will result in high physical IO activity and will decrease the disk performance. While processing the results to the buffer, CPU resources are also used. The typical ratio for user calls to read from the data buffer is well tuned. Basically, for a well-defined, it should be between 1 to 15. This is the average number of buffer blocks that are read to process a statement. If this ratio is significantly higher, it is a good indicator that the shared SQL area needs to be carefully analyzed for expensive statements. Okay, first point. Let's get into the first point that we saw is the quality. So quality depends on the hit ratio, data buffer hit rate. Okay, so basically the ratio of physical reads per total reads in the data buffer hit rate. This hit rate is displayed in the database overview monitor, that is ST04, and should be at least 94%. Then next, examine the data buffer hit rate. A data buffer hit rate of 94% or greater doesn't mean the buffer is large enough. Okay, expensive select statements can increase the data buffer hit rate because they significantly increases the number of successful buffer gets. And if the area ratio of buffer gets to user calls is much greater than 15, the data buffer hit rate is not a useful indicator. Okay, shared SQL area. Okay, basically how we can find that information. Buffer gets for an statement. So how we can find out the buffer gets, that is how much data is coming from the buffer. Okay, then different statements in the shared SQL area. Here we are seeing basically a sample SQL statement which is showing the different components, like which component is doing what. Okay, next let's get into analyzing SQL statements. Okay, here you can see that this is a select statement. Select mandate VBELN OBJ NR from Z VBAC table, where mandate is 001 and name is Ernie. Okay, so here records specified by the where clause. Okay, so where this client is 001, and there is an AND statement where the name, this is the name. So this is the select statement making of two parts. So record specified by the where clause. Search area, this is the search area, the data that is searched through for the requested record. Okay, so this is the SQL statement. This is an example of SQL statement. Then expensive SQL statement. The optimizer chooses an unsuitable access path. Symptom is many buffer gets, only a few records per execution. Okay, so this is a key indicator. Basically, what is happening is many buffer gets and only a few records per execution. So here you can see that there are two types of statement. Type 1 statement search through a lot of data for only a few qualified records. Here the optimizer chooses an unsuitable path to access the data. Then type 2 statement is basically request a lot of records. Here the optimizer chooses a suitable access path. So in this example, what we are seeing is the application requests the record of table Z VBAC, where mandate equals 001, and the name of person who created the record or object. Many records are read, although only 2 are requested. Therefore, the statement is of type 2. Okay, now here we are seeing basically the optimizer chooses an unsuitable path. In this case, many buffer gets but only a few records per execution. So statement of type 1 may be accelerated by. Okay, so this type of statement, how do we accelerate this type of statement? Update the optimizer statistics. That is the most important thing. For any performance within SAP, just make sure that you have the optimizer statistics updated all the time. So you can schedule a job to do it daily basis. You can schedule a job to do it at night or morning basis, depending on what works for the business. Then change of the ABAP code, optimizing user input, creating an index, extending an index, and dropping an existing index. Okay, so expensive SQL statement here, basically the record specified by the where clause. Okay, now this is type 2. Basically the optimizer chooses a suitable access path. Symptom: many buffer gets and many records per execution. Okay, so in this case we need to tune the business process, optimize the user input, and change the ABAP code. So analyzing the shared SQL area. So basically what we have seen is check database activity since startup and sort for the following criteria. Basically the buffer gets, disk reads, and records. Okay, we have seen a lot of buffer gets. Now what this buffer gets is, okay, to display the statement that causes the highest database load, sort by buffer gets. Okay, basically we need to sort it by buffer get, then only we can see that which is the maximum number of buffer gets. Okay, buffer gets per execution. Statements with many buffer gets per execution. Okay, per record you are seeing buffer gets per record, per execution, and disk reads. Check statement where the number of disk read exceeds 2% of the total disk area. Statement details. Display the execution plan for an SQL statement. Okay, roadmap for finding SQL statements in program, and where used list. Okay, so we just saw the global work process monitor as well, so let me go there. So let's go to the SAP system to show you guys how the global work process monitor looks like. It looks pretty much like the program. Okay, so here you can see these are the different fields which is there in this SM66. Okay, so let's get into the next slide where we are seeing the Oracle session monitor. Okay, differences between the two statements using internal table. Basically I just want you guys to read this text for some time so that you can get a feel of what is explained in this figure. Okay, internal table handlings. Next is the SQL statements to project views. Okay, so now we have seen what it involves. Now let's distribute the responsibility between the developer and the administrator. Okay, index creation, two types of indexes, primary, secondary. Here we can see the Oracle index structure, unique index structure, index range scan, order of field in an index, full table scan. Okay, important execution plan, basically the index unique scan. Index unique scan means a unique index is fully specified. Okay, now this is basically the database cost optimizer. Basically the different options and which is the most expensive or the least expensive one. Okay, rules for creating index. Just take note of these rules. Basically, first thing is only selective fields. Use only selective fields. Use as few fields as possible. Use selective fields at the beginning if possible. Do not create an unselective index. Create as few indexes per table as possible. Do not create an index that can be used unintentionally, and do not change an index created by SAP. Okay, security analysis. Okay, preferential order for possible optimization, basically in which order we should carry out these activities. First thing is run update statistic, change the code, change an index, create a new index. Okay, views. Basically here you are saying what is a view. Okay, so here in this particular figure you can see that a view is a logical object. No physical data is stored in the database, so that is a view. Basically it's a transparent layer. Okay, so let's see how this tables looks like, how these views looks like. So let me go to this particular transaction called SE11. Okay, in this particular transaction, say for example I want to see a table, I can just select it here. Say for example, let's see, I want to see table called VBAP table. Okay, so just display it. Okay, so here you can see that this system is not able to show you VBAC table. Okay, so let's see what tables are there in this particular. So let's see. Here you can see that I am doing a search based on the table name starting with V and ending in D. Okay, so ending in D is, it's a table. Okay, then you can see that these are the different things which is present in a table. Basically which package that is part of, tables, which are the tables, how they are joined. Okay, select condition and maintenance status. Okay, now let's get into something called starting with say I or ending in I. Say ending in I means it is an index. That is a kind of naming convention. It's not hard and fast, but that is a standard practice. Say you can select this as the index. Okay, so index, here you can see these are the different indexes which are present. Okay, so this is about index. Let's keep moving. Let's go to the next slide. Basically talking about the nested statements, preferential order of possible optimization. We just need to make sure that we follow this order. Okay, that's all I wanted to cover in this particular training session. Thanks for joining and have a nice day.